said sit up though. Greetings and welcome, friends. Last night I had you do a Kuta software packet called Add and Subtract Fractions and Mixed Numbers. Now you might be like, Mr. Waddy, isn't this an elementary skill? And I'd say yes. However, it's a skill that many folks, both elementary and not, are not confident with. So that's why I thought it'd be valuable for us to go over, especially since we're expounding upon these concepts later today. Now the big idea is that in order to add or subtract fractions, which by the way, you might find this unusual, but it's more difficult to add and subtract with fractions than it is to multiply or divide them. That's usually the opposite way around for other things. However, in the case of fractions, adding and subtracting is harder because I need a common denominator. So for this problem, I could write this as 6 over 1 minus 1/6, and I'd have to figure out what is the LCD, the least common denominator, between 6 and 1. And what do both of those numbers go into? 6. All right? So I'm not looking for the greatest common factor. I'm looking for the least common multiple is kind of what that is. So I'm going to then, well, this one's already got the common denominator, but this one doesn't. What could I multiply 1 by to get the LCD? And if I need to multiply that by 6, I actually have to multiply the top by 6 as well. You can't just multiply the bottom, because multiplying by 6 over 6, what is 6 over 6 equal to? 1, and 1 is the multiplicative identity, meaning it doesn't do nothing. Right? I multiply by 1, it didn't change nothing. So it's not changing the value, it's just changing the way this problem looks. So in doing so, 6 times 6 is 36 sixths. That's the worst word. Subtracting 1/6. And when I subtract or add, you need a common denominator. In fact, you could even add this intermediate step, which no one would. All right? And then you could think about that as, 35 sixths. So the denominator stays the same. The numerators are the ones that get changed. All right? But that's the idea. You need an LCD. You find that. You multiply each fraction, top and bottom, by the part of the LCD it is missing. All right, very good. Problem 9. Between 8 and 5, what is the LCD? Smallest number they both multiply into. 40. So I'm now going to have to multiply top and bottom, each fraction, by the part of the LCD it's missing. What do I need to multiply 8 by? 5. So 5/5. And this one I'd multiply by 8/8. Ray baby. So I'm going to get negative 4 times 8 is negative 32. 5 times 8 is 40. Minus 7 times 5 is 35. Over 8 times 5 is 40. Now, I don't have to write this all over one denominator. I can just subtract their numerators and then write it over a denominator. So negative 32 minus 35 is getting more negative. So I believe that's negative 67 40ths. And I don't think that's reducible, am I right? I am right. Well, I asked the question, what would I multiply 8 by to get 40? And the same thing with this one. Now, in some cases, you can get a common denominator just by multiplying this denominator by that denominator and multiplying this denominator by that denominator. But that won't always be the least common denominator, and then you might be creating larger numbers for yourself to work with and make it harder to solve or simplify. Last thing here, mixed fractions. Ugh, gross, friends. Gross. The only time mixed fractions are good maybe is like in terms of answering a word problem question. If I was saying I just ran 2 2/5 miles today, rather than saying that I ran 12/5 miles, because no one says that. But as far as doing math work with, we prefer improper fractions, my friends. So the first thing I'm going to do is convert this to an improper. So negative 1 plus, and the way you do that, I don't know if you guys remember the trick, you multiply the denominator by the whole number, so you'd multiply those, and then you take your result and add it to the numerator. So 5 times 2 is 10. 10 plus 2 is 12's. And this is negative. I guess I could actually have gotten rid of this plus sign. Right? Minus 12. And it's still in terms of fifths. Right? So now, in order to combine these, though, these still need a common denominator. This doesn't have a denominator, you say? Oh, well, now it does. So what is the LCD between 1 and 5? Didn't I ask that question earlier? Was that back at the beginning? Oh, it was 6 back then. Good memory, friends. So I can now simply multiply top and bottom by what? 5 fifths. 5 fifths, right? And I'd get negative 5 fifths minus 12 fifths. So now I just subtract those, that becomes more negative, so that's negative 17. And the denominator stays the same. All right? We do not need common denominators for multiplying or dividing, but you do need them for adding and subtracting. Thanks for watching, friends. Tienen un día al más bien del mundo.